Welcome to Cloud On Air Live, webinars from Google Cloud. My name is Andy Chang, and I'm a Senior Product Manager in Google Cloud Security's team. Today we'll be talking about how to protect, detect, and respond to threats with the Cloud Security Command Center. You can ask questions at any time on the platform, and we have Googlers on standby to answer them. So let's get started. Today we're going to be covering an overview of the Cloud Security Command Center and the common situations that enterprise customers find and the concerns they have when they move from their on-premise to cloud, which can be addressed with the Cloud Security Command Center. We'll be talking about threat prevention, threat detection response, demoing the system end-to-end, and also talking about partner integrations, which allow you to use the tools that you're already familiar with in integrated ways with the Cloud Security Command Center. We'll wrap up, and then we'll take questions. When enterprise customers are thinking about moving from on-premise into public cloud, they really have three overall challenges that are addressed. First, they lack the visibility and control that they're used to when they run and wholly manage their own resources. Secondly, they typically have a concern about an inability to detect and respond to threats in the same way that they could in their on-premise cases. And lastly, there's an increase in complexity, both as many private public cloud engagements are different than what they're used to in on-premise in terms of controls and visibility, as well as understanding the new shared responsibility model when they have and are responsible for security in the cloud while the providers are responsible for the security of the cloud. We've created the Cloud Security Command Center to help customers address each of these issues. It allows you to prevent threats through visibility and understanding of what you're running on Google Cloud Platform. In addition, we've enabled native services to allow you to both prevent and detect threats before they turn into breaches and exploits. And lastly, we're able to allow you to really manage and integrate not only native managed Google security services, but the key security services you're already familiar with, all in one place to provide a unified view and platform to allow you really to take control, have the visibility you need to manage the security of what you're running on GCP. We're going to cover three of the detailed areas in each step by step. First, preventing threats. And in terms of preventing threats, we're going to talk about two managed services that Google provides natively, Security Health Analytics and Cloud Security Scanner. In addition, then, we'll be moving to detecting threats, finding bad guys doing bad things on your deployment of GCP. And there again, we have two native security products, the Cloud Anomaly Detection as well as the Event Threat Detection. Finally, once you've found either vulnerabilities or threats, it's important to now respond to them and have a number of options that map and match into your existing workflows. We enable you to easily change the configurations of the cloud. We enable you to trigger and investigate alerts, as well as to trigger and create incidents through our RRM system, and finally, to allow you to trigger actions through Cloud Functions or output the results to the SIEM of your preference. When we talk about preventing threats, we're going to focus on two native Google security products, Security Health Analytics, which we announced to public alpha, as well as the Cloud Security Scanner, which is in general availability for applications built on App Engine and is in public beta for applications built on both GKE and GCE. When analysts have looked at the cause of major incidents and breaches, an overwhelming amount, close to 70%, are caused by misconfiguration. It's one of the first things that's important to address when you migrate from your on-premise facilities that you're familiar with to the new public cloud environments. And as such, Google has created a managed service, Security Health Analytics, to help you address that. So in terms of looking at the overall value of the Cloud Security Command Center, first, it's to provide you really the visibility on what you're actually running in Google Cloud. And what that allows you to do is not only have a look at what you've deployed and you already understand, but in the cases of shadow IT, development teams that are overly aggressive in terms of their deployments, you get a holistic view of all the resources that you're running on Google Cloud Platform in one place with the ability to understand their history, their configurations, and how they've changed. So take inventory of your cloud assets, really view things across the different solutions, infrastructure as service, platform as service, software as service that you've deployed on Google Cloud, and then through Security Health Analytics, allow you to understand the vulnerabilities that may exist or the misconfigurations. We all do this all in one unified platform and give you ability to search and join on the various entities from the assets to the vulnerabilities to their underlying properties and attributes. Specifically for Security Health Analytics, we currently, in the initial launch, surface more than 30 different common checks across a spectrum of the common misconfigurations, whether it's in storage, the classic ability to proactively identify for you publicly exposed buckets to allow you to cut off and prevent data exfiltration before they happen, the ability to understand when you're using legacy ACLs or legacy networks or default networks so that you can, again, have full control of what you're exposed. From a VM standpoint, the ability to understand when you're not using private cloud APIs to access Google services, and also when a common vulnerability like IP forwarding is enabled. From a networking side, we definitely enable you to look at both overly permissive firewalls and also the various types of routing and networks that you're using. From a logging and monitoring, which is key for you to both detect and also to forensically investigate when potential incidents happen, we have a number of checks designed to allow you to understand when you have that actually disabled and when you would need to enable those so you can get the full benefit of the logging and monitoring. And then finally, for GKE clusters, a number of the default health checks through our Google Cloud and GKE recommendations, security recommendations, are also automatically checked by the Security Health Analytics. Security Health Analytics are run twice a day automatically, and as a managed service are part of what you have in the Cloud Security Command Center. In addition, for applications that you're building on GCP, we provide you the Cloud Security Scanner to scan those for common application and web vulnerabilities. And these really fall into three classes. A wide range of cross-site scripting detectors that are built on the same technology we use within Google to test our own applications for cross-site scripting. In addition, we proactively find potentially vulnerable resources that are exposed through your application, whether that's accessible Git repositories, secure libraries, the use of clear text passwords, or weaknesses for continuing to use Rosetta Flash. Finally, we enable you to proactively detect if your applications are misconfigured, either using mixed content, invalid headers, content types, misspelled and misapplied security headers. Collectively, this is part of a free service that, again, applies to any publicly accessible URL or website or IP built on applications that run either on App Engine, GKE, or GCE. Next, once we help you find the potential vulnerabilities, which are the weak points that bad guys can attack, we also look for and help you detect activity on your system that can be malicious, proactively using Google native and Google unique threat intelligence to give you an opinion of what we think about those activities and allow you to make decisions and act. For detecting threats, we focus on two specific detectors built into GCP and are provided as managed services. First is the cloud anomaly detection. Second is the event threat detection, which we announced at Next to private beta. When we think about detecting and responding to threats, again, it's around initially the resources you're running on GCP, and we're looking for either malicious and compromised machines or activities that are indicative of compromised machines taking either threat or abusive behaviors in your system. In addition, we're able to, for event threat detection, look at the logs within Stackdriver that you've enabled so that for the various types of logging, VPC flow logs, firewall logging, audit event logs, we're able to assess those and provide a range of detections proactively as a managed service. The two types of detectors we have are first the cloud anomaly detection, which looks at what's happening behaviorally outside your system, what your system is connecting to, what the type of CPU performance they're running. So we're able to combine those signals using ML built on over 20 years of Google being one of the prime targets on the web, to help you proactively identify threats to your system from information from outside in the environment around your systems. In addition, with the launch of Event Threat Detection, we've now created a log-based system which allows you to drive your Stackdriver logs through Google unique and native proprietary threat intelligence to proactively, again, identify threats in your system. For the case of the cloud anomaly detection, we detect 7 different types of anomalies, which we surface up in the command center. 4 of those are authoritative: our ability to detect coin mining, our ability to detect phishing and DDoS, and our ability to detect service account credentials that have been pushed to Git. And 3 of those are anomaly detections, which would require you to investigate further. Our ability to find either potentially data exfiltration, potentially a compromised machine, or potentially activity that's generally anomalous from the previous experiences we've seen and behaviors we've seen for those instances. On event threat detection, again, we digest the logs from Stackdriver and find 6 basic threats with high confidence in typically sub-minute type timelines. Lastly, to respond to threats, when we think about the options we provide you natively in the platform, we enable you to, through a set of cloud functions, trigger those that allow you to potentially change configurations, to allow you to trigger an alert, a notification out either through email or through our sidecar application into things like Jira or into text messaging. Finally, we allow you to integrate with the Stackdriver Incident Response Management System so that you can manage your security incidents the same way you manage your operational incidents. And lastly, since we know that the Cloud Security Command Center is coming into a heterogeneous environment, that most likely to have existing SIEMs that you also use, you can export your data either in JSON format into GCS buckets or through an application sidecar that we provide, integrate into a SIEM like Splunk. When we think about detecting and responding to threats that target your resources, we now are going to transition over to the demo. So what you see here is an overview of the Cloud Security Command Center. Cloud Security Command Center is an organization-level product. In this case, we have a demo organization, the GCPsec demo org. We're able to look at your assets that you're running, and it has a wide range of Google assets, from the common ones around GCE, GKE, App Engine, Spanner, BigQuery, Cloud SQL, GCS for storage, in addition to your service accounts, images in your container registry, a wide range of other detailed networking and device resources. You're able to see those either in a table view or in a cross view. You're also able to look at the history. So currently, over the last 24 hours, one instance template was created. If we go back to, say, 14 days, you'll see that a number of things have changed in the system. We keep 13 months of history, which allows you to go back and look at forensically the changes in your assets over that full period of time. In addition, currently the asset data is sampled twice a day, which allows you to have multiple views of how your assets have changed from a day-to-day basis. You also have the ability to manually trigger a scan. So all of our customers who are looking at the resource history have the ability either to, at a human level on the dashboard, to trigger a rescan, or through either G-Cloud or the API, programmatically trigger rescans. And many of our customers tie the programmatic rescans into their CI/CD process. In addition to the asset side, we have the findings. The findings are both a set of managed services that we have, as well as where findings would show up for partner services and integrations of third parties. Security Health Analytics gives you a view of the common things that we found automatically through a twice-a-day scanning check. In addition, it's prioritized by severity. The top 4 are highlighted in red or high severity, whereas the default network is a medium severity item. And we tell you the number of those that have been found. In addition, event threat detection gives you a view not only of what's happened within the last 24 hours from a threat, in this case nothing has triggered that in the last 24 hours, but in the last 7 days, a persistence and anomalous IAM grant was detected. We then look at the individual connectors and detectors. and summarize for the various ones that are available. In addition, the Cloud Anomaly Detection gives you a view of the current 7 findings it has on the system. And we integrate data loss prevention, data discovery, so you have a sense of what data is running in your system based on whether they're sitting in GCS buckets, sitting in BigQuery tables, or sitting in data store kinds, so you have a better understanding of the impact any potential breach may have. Cloud Security Scanner has its own dedicated card as well and shows you the web application vulnerabilities that have been in the system. And lastly, we integrate to things like the new enterprise phishing protection that we announced at Next, as well as the open source config and scanning tooling for SETI. Again, for each of those, we give you a summary of the items. You can also look at it in visualization form and provide you kind of this place to go to so that you can see what's happening on your system. The Command Center really has 3 main components: this dashboard component, as well as the inventory components, what we'll show shortly, and then finally the finding details components, where you're going to look at and investigate each of the underlying pieces. You can also, if you want to add third-party sources, go to automatically our marketplace integration, which the third-party partner vendors that you're most familiar with, if they have an integration Cloud Security Command Center, will be here, and then you can trigger those directly. Lastly, you can manage the settings and your ability to control your display through the settings piece, either managing which assets you can actually look at and view, what permissions you want to assign to different members and groups and roles with Command Center. Command Center has a set of 13 dedicated IAM roles, which have built-in separation of duty and privilege that you can assign out with separate reader and editor permissions for each of the underlying resources. And lastly, you can manage the security sources that you're integrating with Command Center. In the case of the native ones, such as threat detection, health analytics, anomaly detection, or things like third parties, such as Qualys or Forseti or Chef, can all be managed here, enabled or disabled from the dashboard. Once you have an overview from the dashboard, the next step is to dive into the actual assets and findings details. Both the 2 inventories have a similar structure. The asset inventory allows you 3 different views of your assets, either at a project level, where you can look at everything at a top-level organization and look at all 3,000 plus assets in one place, including the ability to query on these. So you can query for all the instances across your organization, and this gives you all 103 VMs that are across the organization. It also shows you on a per project basis how many VMs are in each. So if we're going to the Forseti home directly, you can see the 3 instances sitting there. Or if you instead just want to look at things at a project level, you can focus on just the 60 resources within a particular project. If instead of doing things at a project resource hierarchy level, you want to look at things more from an asset centricity, you can simply flip to asset type view, and you'll see the number of resources across your organization by each asset type. Each of these things are sortable. You can sort from greatest to least, least to greatest. You can also use the search. So if you wanted to find Spanner, for example, you can find the Spanner database and Spanner instances directly. Lastly, in addition to the project level view, the asset level view, you also have the ability to look at a time-based change. So what has changed from an asset standpoint in the last 14 days? We can see that 81 assets have been created and 35 have been deleted. You can actually shrink this down to the last 12 hours. You can see in the last 12 hours, there have been 5 instances, 5 items, 2 instances, 2 disks, and a template that have spun up, as well as 5 that have been deleted. In addition to the ability to look at your assets, as we showed before, you have the ability to query. And one of the things you can query for is who has access to different things. So one of the attributes that we have for each of the assets is their IAM policy. So now I can look for a user and find the IAM policies and therefore the IAM roles that that user has. And you can see this user, HI at GCP sec demo org.unix.net, has access to 5 different resources. At the highest level, at the instance, we can see that that person has access as a security admin to this instance. For the Splunk demo, it also has an instance level role. In this case, that person has access as a network viewer. At the SEC demo company Eng demo project, that person has access as an instance admin. That ability to look at which particular owners have access and what the roles are on a resource basis enables you to, again, take the permission and policy information and join it with the rest of the data. In addition, we can go back in time. As I said, we have 13 months of history, so this is what the organization looked like as of today. If we go back to May of 2018, you'll see far fewer number of projects, and all the different attributes, including the marking systems, all have lifetimes and are matched through the time history. Last thing you can do is enable and use the dedicated marking system. So we can say that, for example, this particular project is actually a part of the production environment. So we want to put this and call it its environment production. And at that point, we'll now have created this mark, and then we can actually filter on all the different things that have been marked as production. And this filters down to just the 47 resources that have been marked to production, including the one we just added in. So you have the ability to use the security marks, which are natively only in Command Center, to do organization, to manage incidents, to integrate with workflows in order to be able to manage the state without having the underlying owners outside of Command Center, the underlying resource folks, have a view of what you're doing. And that allows you, especially in incident investigations, to keep your organization and the ways that you're thinking about investigations separate from the bad guys who might be in the system. In addition then, as I said before, the managed service defaults to scan assets twice a day. In addition, you can trigger an automatic rescan manually, and then everything I've been showing you can also be done through the APIs, through the RESTful API, or 4 of the client libraries, 4 different types of client libraries, or through G-Cloud. Lastly, you can export what you have. So for what you've selected, in this case, I've looked at all things marked in production, which allows you to now then export by picking a particular project that you want to export to, picking a bucket in that project, and then allowing you to select the underlying details. And the export is done in JSON. Similarly to the asset inventory, each asset has an underlying detail page. So for example, if we were to look at a bucket like this SEC demos patients, we'll see that at an overview, it tells you when it was seen first, when it was last modified, built-in attributes, underlying resource properties, such as the default ACLs, the various configuration pieces, as well as findings. And so in this case, we know that the bucket-only policy has been disabled on this bucket, logging disabled, and both of these things that Security Health Annex finds or our audit logging can find. If we move to now the findings details, the findings inventory page has a similar structure. It also gives you 3 different views, either by finding type or by the type of detector that has triggered that finding. So you can look at things that are triggered from asset transparency, things that are triggered from our audit log detection, from our binary authorization, anomaly detection, DLP data discovery, security scanner, event threat detection, Forseti integrations, third-party integrations like Qualys, and then Security Health Analytics. In each case, you're able to see what the item is, when the event was discovered, what the source of the detector is, and any marks have been attached to it. So currently, this organization has in total over 10,000, close to 16,000 different detections. You're able also to change whether these are active or inactive. So for example, if I go into my Security Health Analytics and look at one of my underlying detections for weaknesses in the system, like say this public IP address, you'll see that we have for the public IP address a description of what's going on, a link to allow you to reconfigure that if you want to change that, as well as the instructions of what you want to do to it. In addition, if you want that resource and that detection to be muted moving forward, you can disable detections on that resource by adding a mark, which allows you to say, if you want to whitelist it, you allow public IP addresses and set that to true on the particular resource. One of the other things you can do is if you say, well, this one is one that I no longer want to see moving forward, you can set it from active to inactive. And once that's saved, it will move off the underlying view of items that were originally triggered. However, if instead you want to see all of them, you can mark things back and show all the type of findings. And this allows you to see now over, instead of 16,000, over 18,000 findings in place. So you have the ability to control those different items. Finally, again, we have history. We can go back and look at what the state of findings were back in May, a year ago. You can see a substantially lower number of findings. Go back to now. And then again, you can export these. For security health analytics, you're able to look in detail at either summaries of what's going on across this. So there are 56 active findings of network not monitored, or you can investigate in those in specific detail. So I can go look at the finding type, again, using the marks. Line into things for security health analytics, be able to then look at the network not monitored and look at each of the individual ones in detail. And it'll tell you again why we think this is an issue, how to create a metric to turn on that monitoring, where to go to configure the asset, what severity that we've set that for, all as a part of the security health analytics. If we look at instead the anomaly detection and look at how this is set up, we can look at, for example, an end-to-end case of resource coin mining. So in the case of resource coin mining, it's something we discovered back in March 1st, 2019. We understand what project it's a part of, what IP the traffic is from, that it's the Stratum AKI mining pool, and also what the instance that was compromised. Based on the project information, we can now rotate and say, and look at by resource name, the sec demo company IT demo resource, and look at the various things that have been detected against that. So we can see that in addition to the anomaly detection, there's also security health analytics has triggered a number of things like flow logs disabled to logging's disabled. We can go to audit logging and see that on that particular resource, we had changes to the underlying firewall pieces, and we're able to understand and track down where those are. We can also go back in time to March 1, when the actual vulnerability and threat occurred, and take a look at what the state of things were back then. So we see at this point in time, we have audit logs around a firewall rule change, around SSH, which is a likely source of compromise for the underlying device. If we want to investigate this further and understand what data potentially was compromised, we can further go and look at that project, go into the DLP section, and then under this particular project, we're able to see, for example, what type of vulnerability, what type of data is stored in buckets attached to that. You can see there's a great deal of PII stored here. So now, as a result of understanding that that machine was compromised, it's currently being used for coin mining, that the SSH firewall rule was changed around that, and this is the blast radius potentially of the data being compromised. So obviously this is something we'd want to address. In order to address this, we can then go and look at a number of cloud functions that we've built into to allow you to automatically either trigger them manually or through PubSub trigger their immediate effect to change the situation. So we can remove the bucket ACLs, repair firewalls. We can also snapshot the VM. So now if we go back to what we've demoed the ability to tie together the various different pieces, the vulnerability detection, the threat detection, to translate the way through the data, to pivot on a number of items, and also to address and respond to those items through Cloud Functions. So in addition to what we've shown here with native managed services, we have the ability to pull in the finding providers that you're already familiar with and have them easily integrate their data all in one place with the managed native services so that you can now have a view across the various detectors of what are the vulnerabilities, what are the different threats, using tools that you already trust and you've used for a while. All of these leverage these integrations through the RESTful API that we have and through the marketplace so that they're easy to turn on. This is a quick overview of some of the detectors that we've integrated, both Google native ones. We've talked about binary authorization, the DLP API, security scanner, Forseti, our audit logs, anomaly detection, event threat detection, security health analytics, as well as a number of partners who have integrations directly into the Cloud Security Command Center. So in summary, the Cloud Security Command Center is a security management data risk platform for GCP. It enables you as a customer to prevent, detect, and respond to threats on your resources on the Google Cloud Platform. Things to do to get started are to really enable the Security Command Center from the marketplace, to then view the quick start to allow you to get started quickly with assets and then turn on the native detectors, anomaly detection, security scanner, and the DLP data discovery, and then sign up for the private beta and the alpha for event threat detection and security health analytics. And then follow the rest of our documentation to learn how to use the Security Command Center. Now it's time for a quick break. We'll be back in less than a minute with some frequently asked questions. So some questions that you guys have been asking are, what GCP services does Cloud Security Command Center work with? We have a full list in our documentation, but all of the compute ones, GKE, GCE, App Engine, as well as storage items and data services like Google Cloud Storage, BigQuery, Cloud SQL, and GCS for data storage, and Spanner are covered. In addition, security service accounts are assets that we index, and as well as the IAM policies for both at the project level and those that have individual detailed IAM pieces. For more, look into our documentation, because that's just a subset of the services that we cover. In addition, the question is, how does the Cloud Security Command Center work with Stackdriver? There are a couple different ways the Security Command Center works with Stackdriver. First, as a part of the response part, we're integrated with the alpha version of the Stackdriver IRM, so you can create an instance from a Cloud Security Command Center finding, and also once an instance resolved, you can then have that data written back to Command Center to understand the file status. Secondly, through a sidecar application, we're able to generate PubSub, and then you can feed PubSub directly into Stackdriver. How to get started with both security health analytics and event threat detection. Both of those have on their respective pages the sign-up sheets. So sign up, provide the information requested, and then we will get back to you as we queue up, given the high demand, the scheduling of each of the folks onboarding into those products. And then how is the Cloud Security Command Center different from a SIEM like Splunk? Splunk is a great partner of ours and is a great place to integrate multi-cloud information in one place at the log-based level. The Cloud Security Command Center handles predominantly authoritative results, the ability really to take various log inputs like our event threat detection or third-party partner log processing and threat intelligence into one place and cross-connect those authoritative results. It allows you then to take those authoritative results and put them into a SIEM like Splunk so that you already get the benefit of some reduction of data before you use them in our security partners like Splunk. And lastly, how's the Security Command Center priced? All the features that we announced at GA are free to use with no additional charges tied to the use of those integrations or detections. The one piece of pricing is that we do have an upload quota for third-party findings through our RESTful API. So if you're writing findings from outside GCP into the Cloud Security Command Center, then there's a 1 gigabyte per day free quota, beyond which we do charge per gigabyte above that. But if you're writing less than a gigabyte a day into the Cloud Security Command Center, the product is free. So thank you for tuning in. Please visit Cloud on Air to discover more content from Google Cloud experts.